Hey guys, welcome to a 2012 Mechanics Level 2 paper. Believe it or not, this is actually my third time running through this thing, which means that's about 3 hours worth of recording just gone. So I'm understandably a bit annoyed right now, so please just bear with me. I'm gonna do one question at a time. I'm gonna merge them all together at the end, just in case screen recording doesn't decide just to delete my video again. Alrighty, question 1, the trapeze. Alright, Jess is a trapeze artist at the circus. As part of her act, she hangs on a long rope and swings downward. When she gets to the lowest point, she grabs onto Hannah and they keep moving together. Jess has a mass of 65 kilograms and Hannah has a mass of 55 kilograms. Name the important quantity that is conserved as Jess swings down. Okay. So when Jess is in the air, she has a certain amount of gravitational potential energy, and then she swings. When she swings down, that gravitational potential energy is actually converted into kinetic energy. Okay, so we're gonna assume conservation of energy, and that the no energy is no energy is destroyed, but only changed into a different form. Okay, so the important quantity that is conserved is energy. Okay. And all you have to do is state energy, as it says only name the important quantity. So just say energy, and that will give you an achieved grade, okay? Name the important quantity that's conserved as Jess grabs onto Hannah as they move together. Okay, so this is momentum. Jess has an initial momentum of a certain amount, and when she moves and hangs onto Hannah, that's a theoretical collision. And then when they start moving together, that's conservation momentum, assuming that no momentum is lost due to there being just assuming that there are no external forces acting. Okay, so we're just simply gonna say momentum here, and that's another achieved question. So by saying momentum here, we'll get you another achieved. Alright. Immediately after Jess grabs Hannah, they move together at a speed of 5.5 meters per second. Calculate the vertical height that Jess has dropped down. Okay, so this question, it involves momentum and EP and EK. Okay, so you know that when Jess grabs Hannah, right? They now have a combined mass of Jess's mass plus Hannah's mass, and then the question tells you that they are moving at a speed of 5.5 meters per second. So basically, they're telling you what the final momentum is with Jess and Hannah and the speed of 5.5. So basically, we can say P equals to mv, and then we can say initial momentum is equal to final momentum because we're assuming conservation of momentum. Okay. So P equals to mv. Momentum equals to mass times velocity, okay? So the total mass of Jess and Hannah is then moving together, and that's 65 plus 55. 65 plus 55 is 120. And then we're going to multiply that by the speed of 5.5 meters per second. Because they're moving together at speed 5.5 meters per second. And that will give us 660 kg ms minus 1. Okay, so it'll give you 660 kg ms minus 1, okay? It's kg. The unit is kg ms minus 1 because P equals mv and m is measured in kilograms and velocity is measured in meters per second, and they multiply together. So you put them together, kg ms minus 1. Simple. So you know that we found the final momentum, and you know, assuming conservation momentum, the initial momentum must be equal to the final momentum. That means the initial momentum is also equal to 660 kg ms minus 1. Okay, and that means that the initial momentum of Jess moving down is 660 kg ms minus 1, but that's just Jess, okay, with her 65 kilogram weight. Okay, so we know that the momentum of Jess was 660 kilograms meters per second, and that she weighs 65 kilograms, okay? But we don't know the velocity. So basically, we can say 660 equals to 65v. And then we divide 660 by 65, so we get v equals to 660 divided by 65, and that equals to 10.15 meters per second. Okay, so you might think we're done here, but we're actually not done here, because we have to calculate the vertical height, and we don't have the vertical height right now. We only have the speed she's moving at. Okay, so you know the kinetic formula from last year. So EK kinetic motion is equal to half mv squared, and we know the mass and we know the velocity. So Jess is 65 kilograms and she was moving at 10.15 meters per second. Okay, that means she has a certain amount of kinetic energy. Okay, so we're going to calculate that. So EK, substitute the numbers in, so you get EK equals to half 65 times 10.15 squared. That should give us 3,346 point something. I forgot. So 4.5 times 65 times 10.15. Yeah, 3,348.23. And EK is measured in joules. It's amount of energy. Okay. So now we're gonna assume conservation of energy, and that the EP is equal to EK. So the initial gravitational potential energy she had at her highest point is equal to the kinetic energy that she gained. Okay, that nothing has been lost to sound and heat energy. So EP. Okay, substitute it in. So it's 3348.23 equals to mgh. So basically, we know the mass, we know gravity, and we're trying to find height. So basically, we can just say 3348. You know that the mass is 65, and if you multiply by 65, you have to divide by 65 on the other side. So divide by 65, and then divide by mg. So divide by 65 times 9.8 equals to h. And if you work all of that out, it should give you h is 5.26 meters. Okay, one thing to keep in mind here is that this is under the assumption that conservation of momentum and conservation of energy, that the height was 5.26 meters. In a real life situation, some of the energy would have been converted into heat and sound energy, meaning that the real life height would not have been 5.26 meters. It would have been something lower. Okay, but for the sake of calculations, we're going to assume conservation of energy and conservation of momentum, and therefore we get 5.26 meters as our answer. Okay. Okay, so if you get all the way to 5.26 meters, you get an excellence grade. Okay, by finding out the relationship between EP and EK. So that's basically up to here. That's going to get you a merit grade. And to get an achieved grade, you just found the velocity of how fast Jess was moving. Okay, so that's up to here. That's achieved. Alright, okay, we're going to be moving on now. In the diagram below, draw an arrow to show the direction of tension force when Jess is at the lowest point in her swing. Okay. So you know that in order for centripetal, for a circular motion to occur, there has to be a centripetal force acting towards the center, okay? And there has to be an unbalanced force for that centripetal force, because there's an unbalanced force, and then that means there's a change in velocity, and the magnitude of the velocity is constant, but then the direction is always changing, meaning because velocity is defined as a vector quantity, and there's both magnitude and direction. That means because there's always a change in direction, that means the velocity is always changing. Okay. The tension force is provided by the string that Jess is tied to. Okay. So basically the string. Sorry about that. What was that? Okay. So basically the string pulls her in the circle. Okay. So remember the centripetal. Sorry. So basically the centripetal force always acts towards the center, okay? Always acts from the object and towards the center. So this will be the centripetal force here. From the object to the center. So that's just an achieved question. pretty basic achieve question here, x towards the center, okay? Okay, Jess is moving in a circular path. When she gets to the lowest point in her swing, and just before she grabs onto Hannah, the tension force in the rope is greater than the gravity force acting on her. Okay, so let's just draw... why is it this stuff here? Okay, so just imagine a circle here, okay? And then there's a... Sorry, it's not a very good circle, okay? So there's a centripetal force acting here from the object. So this is Jess here. From the object upwards to the center of the circle, and there's a FG acting downwards. Let's just say, for an example, that the FG was larger than the force acting upwards. Because the FG is larger than the force acting upwards, then Jess will begin to accelerate downwards, and that's no good for anybody. So the reason that the tension force is greater than the gravity force is because there's an unbalanced centripetal force that's needed to pull Jess around in a circle, okay? But the unbalanced force is the difference between the centripetal force and the FG. So it's basically just vector addition, like vector subtraction, vector addition, okay? And yeah, it's basically, that's what the question is asking. So like explaining why the tension force is greater than the gravity force. So how are we going to answer this question right here? We're just going to say, so during the lowest point of her swing, there is a centripetal force acting towards the center and upwards. This force must be greater than the force FG acting downwards, as this unbalanced force is required to pull Jess in a circular motion. The difference between the centripetal tension force and the FG is the unbalanced force. And yeah, because it's basically the force is acting upwards, the centripetal force, and then there's a FG acting downwards. The centripetal force is greater than the FG, so there's a unbalanced force that pulls her around in a circle. That's basically it. There's not much to this question, so that would be your answer. So getting all of this should be an excellence grade. Oh god. Yeah, it should be an E grade here. E grade. To get a merit grade, you're looking. So you're just gonna say Hannah is moving in a circle, so there must be a centripetal force. So if an object is moving in a circle, there must be a centripetal force and an unbalanced force to act in that circle. And you have to say where the centripetal force comes from. So basically, you say that the centripetal force comes from the string, okay? Oh, I actually didn't say this. Okay, that's something I missed out in this answer, so that's my bad. So you have to say, so the centripetal force is provided by the tension force of the string. Sorry about that. That was my mistake. That was pretty stupid of me to do that. But just remember, yeah, as for an cheat, you say that Hannah is moving in a circle because of centripetal force, or you can say that the centripetal force is provided by the rope. Okay, so like for a cheat, it's either one of them, but for merit, you need both. Okay, but you're obviously aiming for excellence, so like you're probably looking for a comprehensive explanation. Okay. Oh well, so I'm gonna cut question 1 here because my last video, which was about 90 minutes long, got cut off due to it being too long and it didn't get saved, so I'm a bit disappointed by that. I've been filming since about 4:30, so I'm a bit tired, so I'm gonna stop here and I'm gonna record question 2. I'm gonna post these on YouTube separately, okay? Thanks for watching, okay? Hope I'll see you in question 2. Cheers. And if there's anything that you don't think I explained very well, if there's anything that's confusing, for example, if there's something that I didn't explain well, or you're still confused, please comment down below. Leave constructive criticism. And finally, don't forget to like, subscribe to my channel for more updates. Yeah, Cheers. See you in the next. See you in chapter 2. Not chapter 2. See you in question 2. Cheers. Thank you. Bye.